Here we have some examples. In this particular example, we have to find the centroid of the circular arc. Here you have to remember, centroid is the geometric center. So a simple line at a distance r has been sketched, and we have the angles alpha above the arc and alpha below the arc. And as you can see, this is one alpha and this is the second alpha. Both the angles are same, and you have to find the centroid of this shape, center of the circle, for radius r. Now, first thing is, we know we have strategically placed the circle and introduced this line of intersection as x. Now we know the symmetric angle are going along x-axis and y-axis, so we know that y prime will become 0. Only thing we have to find is now on which point of this line does the centroid exist. The first thing is first, as you know, we can write this thing as x prime is equal to integral, since we have to find x over d, what now, dl. This is a simple chord, and you can treat it as area also. The centroid of this area can be defined as, since we are using this area, so we are going to say r theta, and for this particular r theta you are going to find the centroid of these along this x-axis. The first thing is integration and r cos theta. Where did you get r cos theta from? As you can see in the figure, since we are moving along x-axis, we are only interested of the projection of r on x-axis. So r theta is the any small angle about the small you can say angle on the chord, that is d theta, for a fixed radius, that is the from center to the chord length defined by r, and we are going to find this projection as cos of theta. So the rate at which is moving is r theta, small triangular area, right here, and r d theta. This is the how you are going to talk about the chord length, that is L. And now we have to find out the complete length L. The complete length L is defined as pi alpha, or you can say r alpha. As you can know, s is equal to r theta. You can say theta is here, r times alpha is going to give you from x-axis to this point the value of the chord, the length of the chord, multiplied by 2. You are going to get symmetric up and down the x-axis, two lengths. So you will have r alpha and r alpha. 2 times of r alpha is defined as L. So you got L is equal to 2 alpha r, and this is what you will get. This is what your equation will look like. And all you have to do is divide this, solve this integral and divide it by 2 alpha r. You're going to find the position of x prime. Now, in case of a semicircle, you can see if you put alpha is equal to if we have alpha is equal to 2 pi, alpha is equal to pi, not circle, semicircle, and you're going to find that the x prime will become 2 pi r, 2 r by pi along x-axis, and this is where your alpha will exist. Alpha is going to x prime is going to exist. As a result, you will have the centroid of a semicircle. Similarly, if you need to find the centroid of an area, the first was the chord, simple length line. Now we have to find the centroid of a triangle of height h, and as you can see, you can place this triangle. It will have 2 dimensions. This means x prime and y prime. So we know the area is defined as x dy, and by similar, so we can solve this thing by simply one integration, and we can say that let a very small slice defined as dy of a can move up and down along y-axis, and based on that small dy we can assume that y-axis is equal to be a perfect symmetrical shape of rectangle with the area cross-sectional area of dA is equal to x dy. That is your area A. If we solve this area A and put it in our actual equation, a dy integral y dA, so we know that y times your simple dA. So here you can say y times x dy. So what is the value of, how can we say the value of x should be? So you can say in basic triangle you can find out the value of x is equal to x, this relation with respect to base and height, and we put this value of x into the equation, and you're going to find, you're going to get this type form from the equation is going to turn something into your like this. Now remember, this is for small area and this is for the entire area distribution. It's just say, if you remember, the basic area of a triangle is breadth times height halved into breadth times height. And if you talk about the variation along x-axis, this means your breadth is going to change. Accordingly, also your height is also going to change. So how is it going to change? You say x over h minus y. If you remember. So these two ratios, breadth into height over x over, that is x over h minus y, this relation is going to become your basis of the cross-sectional area. And we have solved this thing, and you will find this is to be 1/3 of its height. This is how you solve for the simple area. This technique is just to show you how masses are, or you can find the centroid of the system based on the equations given above.